And I will be chairing the session. You can see, well, you could see the name. We're going to continue in the same parallel theme of research infrastructure ecosystems, right, that Andre Radil opened up this morning. And in this case, we're going to be focusing, so the idea is to learn about the diversity of research infrastructure in terms of large, small, et cetera. And in this occasion, it's more about the geographic diversity, the geographic dispersion. And the speakers are going to be showing us different perspectives from different regions in the world. And from these perspectives also maybe, giving some examples as to how connecting different sites, so these are multinational infrastructures, be them intra-continental or transcontinental, how these interactions are really being useful for research infrastructures to work better, right? So this is the idea, and we're delighted to have a panel, well, 2 on-site speakers right here and 2 that are speaking from North America and from South America that will be remotely speaking today. So let me start right away with Silke Schumacher. And, well, she's the current hub coordinator of an ERIC, an European Research Infrastructure Consortium called Instruct. And she will be giving us the European perspective. Thank you, Silke.
Okay, good afternoon, and thank you, Alejandro, for the invitation and the opportunity for me to present the European perspective in a global endeavor. And so I present Instruct to you, which is a distributed research infrastructure in structural biology. And we study the building blocks of the life in form of proteins and DNA by using complicated technical equipment and installations. And we've been central in the development of new vaccines and treatments during the COVID-19 pandemic. So in terms, we are funded by 14 members that are spread across Europe. EMBL is a member as an intergovernmental organization, and then 13 countries. Of these 14 countries, 11 have established what we call centers, specialized facilities that are established in their countries that are operated at the national level to provide services, training, the opportunity to internships and organize training activities. And this is then coordinated by the central hub, which is located in Oxford in the UK. So this is an overview of the center. So in total, we have 27 facilities that are operated in 11 countries. And you can see from the types of facilities that this is really wide range of ranging all the way from protein production to synchrotrons. And so the types of services that we offer are sample preparation, biomolecular analysis, and 3D structure analysis. And we have more than 75 services that are operated by the 11 centers. So the opening a research infrastructure, a European research infrastructure to the world requires democratized access to this infrastructure, and we think that this is critical to the benefit of global science. We mean that global diversity means experts in specific fields are distributed around the world, but still need to have access to centralized advanced facilities. And this was very much highlighted with the urgency during the COVID-19 pandemic. The core aims of our bi-regional collaboration project, EU-LAC-RES-Infra, is to promote internationalization of RIs from both Latin America and Europe and reinforce thereby the EU-LAC cooperation. We perform human capital development, training, and capacity building. So the way of Instruct towards becoming more global started with individual collaboration at the institutional level. We will sign a memorandum of understanding tomorrow with the Brazilian synchrotron facility and cryo-EM facility. And this is really also how many of these collaborations were started in the past. It's an opportunity for us to network, to communicate, and to collaborate. And we have been, in the recent years, been able to organize international calls for access and have had long-term staff exchanges and international symposia. And we've also been able to identify potential barriers to international access. So as an example, this is an overview, a map of the world of the cooperations that we've had in the last few years. And you can see that it really spreads across all continents in various different ways through workshops, MOU signatures, training activities, and there's really a whole range and diversity of different interactions that have taken place. The RIVIS project, which is was a Horizon 2020 funded project that ended in January this year, allowed us to expand our international outreach even further by being able to organize 3 different symposia. The first one with Africa, the second with Latin America, and the last one with Australia. And you can see the number of attendees of these symposia, which was a very good opportunity to network and communicate and to discuss common issues between these different parts of the world. So we have been able to also launch international calls for user access, and the second call was organized together with INEX and the EU-LAC-RES-Infra, and the third call is in preparation to be launched before the end of this year together with MOSPRI. We've had staff exchanges, longer term ones, which ranged of 9 to 12 months to really allow non-European scientists to spend a significant amount of time in facilities at the Instruct centers to learn new techniques and to enter into collaboration with scientists from the Instruct centers. We are participants in a number of EU projects that also promote user access globally, including EasyDoor, CanSurf, and INEX Discovery, among many others. So in terms of the second international call for access, this is an illustration of what happened. The applicants from Latin America and, in this case, South Africa, were able to, 8 researchers were able to visit laboratories facilities in the Instruct member states, ranging from UK to Finland, MBIL, France, Italy, and Spain. And you can see that this is a very good activity. It's not very large, but it's a good start that also showed us what the obstacles of such courts are and how to best handle these collaborations across large distances. So the names of the people who participate in the staff exchanges, Alejandro is sitting in the audience. So he came from the Institut Pasteur in Montevideo and to spend some time at CNB, CSIC in Madrid. Leonardo Alonso visited MBIL Hamburg, coming from University of Buenos Aires, and Roberto Salinas visited Utrecht University, coming from University of Sao Paulo. So these are examples of more senior scientists that spend some time in Instruct centers in Europe to learn new techniques and to collaborate. So we also did a survey, International Cooperation Service, as part of the IRIS project to identify what potential barriers could be. And the results are that it's limited time, resources, and funding. Sometimes the maturity of own institutions is a bottleneck, and establishing legal forms for collaborations, and the need to further develop an international strategy. The COVID-19 pandemic was a big obstacle for all of us, and the overall lack of government support was identified in the course of the IRIS project. We also did a more thorough analysis, landscape analysis with 157 structural biologists in Latin America, and carried out interviews with 29 researchers to get more in-depth information as to what the issues are. And you see a list of the key barriers which relate to funding, bureaucracy, size of community, lack of new students, lack of training, and maintenance of equipment problems. And so this report has been published. This was launched 3 days ago at an ULAC Res Infra site event in the presence of some of the Latin American participants of the project also. So for me, the takeaway points are that European infrastructures have opened their doors to the world, often with EU funding, such as EU-LAC Res Infra or RIVIS. SRA has guided the development of research infrastructures in Europe as a central organization, and this is good because this new legal form has solved some of the bottlenecks for infrastructures delivery in Europe. But the internationalization of ERICs is still very much under development. So thank you very much, and I'm happy to take questions. I forgot the thank you. Yeah.
Thank you very much. And we have time for questions for Silke from the audience. I forgot to tell that the idea is to have some time after each speaker for questions, and then we will have a little bit of time at the end to have a final wrap-up discussion. Carlos. Oh, maybe, yeah. Thank you.
So congratulations for the talk and what you are doing. I was wondering why Switzerland and Austria, two of the most innovative economies in the world, are not part of of the consortium? Do you have any idea?
Lack of time to recruit new members is the reason. Yeah. Okay. So we have actually quite a whole set of scientists in Austria that are interested in joining Instruct, and this is the next one on my list to pursue. Yeah.
I'm wondering how it actually works, the cooperation with synchrotrons from the practical perspective. Do you purchase services from them? Do you elicit a collaboration that it's for you cost-free, or how does it work?
Maybe you want to answer this. Yeah.
Maybe the microphone.
Yeah. So I introduce Claudia Elena Amaro, who's overseeing access provision at Instruct.
Then Diamond and newly integrated EMBL Hamburg are Instruct centers. Then our model is, there are two parts of the contributions of each country. One part is the fee that pays for the central activities and for the travel and for the consumables. And the other part is the in-kind contribution, that each country, member of Instruct, funds their own infrastructure, and a percentage of the access of their infrastructure is used for transnational access. Then people go to Diamond or go to EMBL, the EMBL beamline, and they use the facilities in that manner. Then this is our model. And when a country joins in and doesn't have a center, the expectation is that one day they will. And we have countries like Portugal and Slovakia who have research sites at the moment. They are not offering access yet, but we are hoping that through this collaboration, eventually they will be ready to. Then this is our model and how we operate.
Thank you, Claudia.
Thanks a lot, Silke, for an excellent overview on the structure biology at the international level. And I would, it's more a comment than a question, like to echo that we see the same in the bioimaging community, the response rate, but there is, so the difficulty is really to keep those projects alive after they come to an end, because at the international level it's even more difficult to find sustainable funding. And at the moment, I think we see that private funders are quite interested in this domain, but we have to live up at the national level to make them aware how important international collaboration is, and that we can chip into the international collaboration here as well, so that we are not, after 2 years of exciting international collaboration and user access, come to an end point.
Sorry, but just taking some minutes. So I was going to ask Silke, and maybe is in the same line that Antti just said. So you have rather strong history, a successful history of coordinating among the European countries. And that means interacting with governmental and non-governmental authorities, officials, and such. When it comes to transcontinental, international cooperation, what is your experience in terms of the need and the reality of interacting with those other governments?
So the need is definitely...
Because it's a little bit what
of
way,
course.
Right?
I mean, in the end, it's the same, whether you deal with European governments or whether you deal with Latin America or African government. It's similar structure, similar people that are involved in the decision-making processes. And for each country, unfortunately, this is true in Europe, but it's also true in the rest of the world. You need to understand the structures, government structures, funding structures, enough to be able to get some funding, some support for any new activities. And so the EU and Europe EU framework program is a good way, because that's easy in a way to get funding for. But if you want to bridge this to, as Antje said, to the national, our member states, this becomes much more difficult. Yeah.
Thank you very much, Silke, again. And we should, yeah, please, let's thank Silke. And we will move on to the next speaker. And let me find my own notes. So we're going to have her online. And let me introduce Oduna Anizoto, if I'm pronouncing it right, Udunna. Thank you very much for being there from Montreal. So Udunna is actually at the Department of Neurology and Neurosurgery in McGill University in Montreal. And she's a specialist in bioimaging. And the good thing about Udunna is that she will be trying to give a combined perspective, because she's Nigerian and she worked in Nigeria, but she's now based in North America and working very hard there and working in research infrastructure. So the idea with Udunna is we're going to hear and learn how she thinks about this combination. Thank you, Udunna.
Thank you very much. Can you guys hear me? Yes? Okay. So good morning from Montreal, and like Alejandro said, I sort of wear two hats. I'm dual citizen, so I am Canadian by birth and Nigerian by heritage, and I also work in Nigeria as well as here in Montreal. So I'm going to try to give you both perspectives, and it's actually, this is why a forum like this is really great, because then we can learn from each sort of side of the coin and see how we can enhance the other side of the coin, which is the African side. This is my lab. My lab is a multimodal imaging lab. We focus on neurodegenerative disease. Multimodal because we use two types of biomedical imaging modalities. We use positron emission tomography, so PET, and we also use MRI, so magnetic resonance imaging. I have a dynamic lab of 7 students. This is just a flavor of what we do. And we're able to do this because we do have the infrastructure in place to do this. The infrastructure ranges from preclinical, so we do preclinical and clinical research. So we do have a preclinical PET and MR system. We also do have a clinical system, a hybrid. So this is where the PET detectors are integrated into the MRI. So it's a hybrid modality, which allows us to simultaneously image the PET component and the MR component of the information we're getting from the individual. And this infrastructure, so this both the clinical and the preclinical infrastructure are supported by a rich facility that includes the cyclotron, because you have to be able to make those positron emission tomography tracers. And we have an animal vivarium, and we do have a lot of other key infrastructures. I'm just showing here one very, very expensive piece of equipment, which is the automated blood sampling system. And it's very expensive because this had to be MR compatible. So we're able to do this type of research because we do have these types of infrastructure. And this infrastructure is supported by a large number of people. We have the core group. Now, what I'm showing you is the infrastructure that I worked at over the past 3 years at Lawson Health Research Institute, which is where I first started before I moved to McGill in January. I'm highlighting this because, the fact that here in Canada, we are actually sort of well supported through research funding, and I'll talk about that in a second, that allows us to actually do research in one area. And for like myself that moved to Montreal, I'm actually now able to start to do the same research because some of these infrastructures are kind of similar or set up in some way across the country. So this infrastructure is supported by a core group of physicists, animal technicians, radiographers or technologists. But we also do have a clinical and preclinical scientists. So we have the people that are interested in neurology, people that are interested in cardiac, in oncology, in psychiatry, in nephrology. And because of this rich network of scientists that we collaborate with, we're able to actually get funding to keep running and maintaining this infrastructure and be able to do the research that we do. And some of these funding are listed here. So I think for both the Canadian perspective or the African perspective or a global perspective in general, I think to sustain and gain value in terms of your research infrastructure, these are very, very expensive facilities that require a lot of effort to install and to operate. Those sustain and maintain those research infrastructures, we need to have trained experts that are actually working there. We need to have a collaborative network that will support and use and utilize that infrastructure and sort of drive it to do what we think it's capable of doing. And then we also need stable funding to replace the infrastructure. So for example, this is a PET MRI system that we got in 2012 when I was at Lawson Health Research Institute in London, Ontario. We got this in 2012. Now the scanner is kind of reaching its sort of typical end of life. It's now close to 10 years. So we're now thinking about replacing it. And so we now have to, again, tap into stable funding. This infrastructure was, when we bought the PET MRI in 2012, we got it through the Canadian Foundation for Innovation, so CFI. And I'm sure that sometime during yesterday or today, Heidi and Cynthia are somewhere in the crowd. They are from the CFI, so they're from the Canadian Foundation for Innovation. And this is where we get majority of a big research infrastructures from, so the multi-million-dollar infrastructures like the PET-MR. And hopefully we'll maybe tapping into this again to maybe see if we can get this infrastructure replaced. And this is the reason I brought this up, CFI, is because, like I said, I'm now in McGill, and McGill does not have a PET MRI system, which is basically the bread and butter of my research program. But one thing that I was happy to know when I moved to McGill is that there is a mechanism for me to actually start to look into acquiring that infrastructure. And so, for example, CFI has the John R. Evans Leaders Fund, so the GEL Fund, which is sort of fund that's available to new recruits or early career researchers like myself to tap into. And there's enough funding there for me to actually start to get to look at infrastructure. And on Monday, I submitted a grant to get a PET MRI system at McGill, and fingers crossed that I'll get that grant. But the idea is that this mechanism is available in Canada to allow us to acquire and actually be able to sustain and maintain our research infrastructure. Now I'm switching hats now because of time and sort of looking at the other end of the spectrum. So we're going from well-researched parts of the world like Canada to the least resourced or limited resource parts of the world like Africa. And Africa is probably the least of all the least part. And I'm not going to talk about the challenges and the overlapping problems with being able to install and operate a research infrastructure in Africa. I think it's very, very obvious. What I want to do is actually focus on what I think that we could do in order to sustain infrastructures when we do have them in place. And, for us to build sustainable biomedical research infrastructure in Africa, and I'm using biomedical imaging here because the same idea would thread through if you're doing bioimaging, so if you're having a microscopy facility, if we're doing, like somebody mentioned, light synchrotron facilities, or any other research infrastructure you're thinking about. I think this cuts across all types of research infrastructure. So we need to have trained experts. In Africa, there's very limited amount of trained experts. There is brain drain and hemorrhage of talents that are, when you train them, you can retain them. So we have to figure out a way to train and retain them so they could work in this research infrastructure. We also have to form collaborative networks. I talked about the fact that a PET MRI program or imaging programs across Canada, most of them are sustained and maintained and run well because they have a collaborative network of researchers that come from different research fields to use that particular infrastructure. So you need to have that collaborative network. And for Africa, you may have to expand that network beyond a country and actually expand it within the region so you can sustain and maintain that infrastructure. And stable funding, and that's going to be a big challenge of how do we get stable funding from the regional, national governments to be able to buy multi-million-dollar equipments, install and operate them, because it's not just installation, it's operation, a long-term operation of those systems that actually becomes a challenge. I don't have answers to all of them, but what I'm going to do is say, first of all, that we can sort of do this with all these challenges that we have. And the reason why I know we can is because we're already starting to do this. Because of time, I'm going to just give you two examples. This is an example using the Cape University's Body Imaging Center, so CUBIC. and the Medical Artificial Intelligence Lab, my lab in Nigeria. So CUBIC is in, obviously, Cape Town, so that's in South Africa, and Medical Artificial Intelligence Lab is in Lagos, Nigeria. CUBIC has been running for over a decade, more than a decade, I think way past 2010. And the Medical Artificial Intelligence Lab was just launched 2 weeks ago in Nigeria. So I was there a couple weeks ago. And so the reason I'm using these two examples is because there's a historical way of doing this, and sort of the part of Africa that has a little bit more resources. And there's also a way we can do this now in parts of Africa that are not as highly resourced, let's say for South Africa. So I'm going to use this as an example to again illustrate why we need trained experts, why we need stable funding, and why we need to have a collaborative network. So let's start with CUBIC. So CUBIC is a joint effort between University of Cape Town, Stellenbosch, and Medical Research Council of South Africa, and the Siemens Healthineers. So Siemens Healthineers, this is a vendor that's one of the key vendors that sort of manufactures, original equipment manufacturers of our biomedical scanners, so MRIs, CTs, or PET scanners. They are the ones that tend to one of the bigger vendors in the market, and it's really nice to see that they've partnered with CUBIC to provide them with infrastructure. Now, the infrastructure that CUBIC has is the whole body 3T MRI system, the whole body PET CT. These are actually fairly new scanners, like scanners that we have here in the West. And I'm going to show you why this is really important to make sure that the infrastructures are also up to scale to what we do here in the West. I mean, they're very expensive. These are very hard to run systems. They're very power intensive. I know the 3T requires helium, so it's not a very cheap system to buy, or let's say it's not a low cost mechanism scanner. But it's important to have some of this research infrastructure in the region. I have Anesta here, Dr. Menkes, who is fabulous, very brilliant medical physicist, who had the vision to sort of set up the state-of-the-art research infrastructure. So it's not a clinical infrastructure, it's a research infrastructure, but now they sort of been able to sustain this by getting clinical dollars to run a research biomedical imaging facility. The reason I put this up here is to show you an example of what accessories you need for just to run the MRI, and if you want to do research. And some of these accessories are not cheap, right? So it's just a gamut of everything from the coils that you need to the software to the phantoms to do some quality controls and harmonization. So these are not like getting the scanner is one thing, but the infrastructure, the additional accessories that you need to maintain and be able to run the infrastructure up to par to be able to do research that you want is actually an other added cost. And here at CUBIC, they're able to do this, and mostly because they had a really good partnership with the vendor, with Siemens. I talked about trained experts in place, and ESSA was really great with finding and training people, researchers, and now run and manage the center. Well-trained technical staff that do acquire the MR and the PET images, administrative staff, and there's a lot of students have gone through the CUBIC training program. In terms of funding, they do have a wealth of funding, mostly from philanthropy, so Bill and Melinda Gates Foundation, the Technology Innovation Agency, which is a South African. So these, the National Research Foundation, it's a South African funding source. Aspen, so this is by Farmer, and then obviously Siemens. So again, this is where the vendor comes in to help with being able to sustain that infrastructure by giving them an extended warranty. So basically giving them a little bit of break on their warranties. And warranties are very, very expensive for MRI systems. They run almost close to $500,000 a year. So it's not really cost effective if you don't have that type of vendor support. Now, by having this world-class research facility since 2010, they've been able to push out 175 publications, almost a rival what we do here in Canada and pretty much most centers in the US. I wanted to highlight this recent paper from the group because this is, again, why it's good to have infrastructure that is comparable to what we have here in the West. I think, I'm not sure if any of the sessions during this conference have talked about low cost, what's the other fancy words, frugal, some of those portable or mobile or cheaper options. I mean, there's a place for that, but there's also a place for having research facilities and infrastructure that's very comparable. So we can actually start to do multi-site studies, especially if we're talking about biomedical imaging that's very clinical focused. And we wanted to do clinical translation research. We want to be able to do that with other sites across the globe. And this is what they could do at Cubic, because they have the same type of let's say capacity. They have the 3 Tesla MRI scanner. They have the actual type of coils that was needed for this study. And they do have the phantoms to do the harmonization. So this paper was looking at a way to harmonize MRI sequences for a specific study. So to study obsessive compulsive disorder and be able to study this across 5 sites in the world globally and be able to acquire the similar images and then pull the data together. And because Cubic has the infrastructure, they train experts, so techs that could actually acquire the advanced MRI sequences they want to run. And again, being able to sustain and maintain that, they're able to participate and sort of be part of global research. They do have a fabulous training facility because of the infrastructure they have and the trained personnel. They can now run a gamut of training programs. This one was just done a couple weeks ago. So they did a cardiovascular MRI training program, and they're very well, I mean, the group at UCT and Cubic are very well renowned in terms of cardiac MRI. They do push out a lot of papers on cardiac MRI, so they're very quite respected in the field. If you want to learn more about Cubic,
sorry, you have 2 minutes.
I'll be done in 2 minutes. If you want to learn more about Cubic, the video is up on their website. I would say to go and look at that. Now, quickly switching hats to what we just started doing a couple weeks ago. And again, this is trying to do this in a lower resource setting. This is a lab that we sort of set up in Lagos, Nigeria, with the interest of, with the intention of being able to do artificial intelligence, or apply artificial intelligence to medical imaging to sort of solve some of the problems. This is a collaboration between Dr. Fatade, who owns a private clinic in Nigeria, radiology clinic in Nigeria, myself, and supported by other researchers and a let's say collaborative partner that's giving us cloud support. The infrastructure, I'm not going to go into that, but essentially we do have infrastructure that can actually allow us to now do AI sort of the way I would have done it here if I was in Canada. And the reason we could do that is because the clinic already has the infrastructure. They have the 24-hour power supply. They have a well-cooled environment, so we can actually run and set up servers. And they already have MRI scanners in their centers. We can actually start to even do our own research, acquire our own images, and do AI in the lab. We do have a training space. I'm not going to get into that. Because of the work we've been doing through camera, and I think Alejandro may have mentioned that, so being able to pull in a network of MR experts, we're able to actually start off with an actual staff already in place, including PIs, an IT and a computational physicist in place. We have funding for at least a couple of years. And we have a bunch of projects, which I'm not going to get into right now. And we're actually trying to do a training program next year because we have the space for that. Publications, we just started, but because we already have a vision of where we want to go in the future, we're able to actually start to share that vision and describe what we want to do in a recent paper in Radiology AI. What we're hoping to do is sort of learn a little bit from what Cubic has done, find those vendor partners, start to train experts to work and stay in that space, create a collaborative network so people can actually make use of that AI, the MyLab, and optimize the infrastructure we have in place. So what I'm going to do and how I'm going to end this is by sort of pleading to the global community to sort of partner with the infrastructures that are already in the ground in Africa and try to optimize them, form a collaborative network with them, and help them train experts in place, because that's how they will sustain the biomedical research infrastructures in the absence of funding from their regional governments. I'm going to end here. Thank you so much.
Thank you so much, Udunna. And we will have time in the end to discuss. So for the sake of time, we will move on to the next speaker. And there's going to be certainly some questions for Udunna in the end. So let me rapidly go to our next speaker, who is Jane Fitzpatrick. And we're moving actually 14 hours from Montreal to Brisbane. And that was a problem for us to meet together and organize this, but that's another story. So, and Jane, I'm not looking now at the right place. Yeah, so she's the CEO of the Australian National Fabrication Facility. So also moving a little bit in subject, the Australian perspective.
Well, thank you very much, and thank you for the opportunity to talk to you here today. Yes, I am here from Australia. Those of you who are more European might guess that I'm not born and bred in Australia. So I have got I'm Irish by birth, but I've now spent the last 18 years in Australia. And for my sins, 12 of those have been involved with the ANFF, which is an organisation that I truly believe has an awful lot to share and a lot to commiserate with all the people in the room, because we all have the same challenges and the same problems. Just to give you a very small bit of background, the ANFF is the Australian National Fabrication Facility. We're based in the National Collaborative Research Infrastructure Strategy, which is the Australian national effort to coordinate research infrastructure across the country. Australia is a small country, so we want to get the best value out of the money that we put into our research infrastructure. We're 15 years old this year, so we have a bit of history behind us. And, you know, again, that comes back to that stable funding. We've had 15 years of funding, some of it not as stable and long-term as we would have liked, but certainly at the moment we're in a very comfortable position. So I'm very thankful for that. So for those of you who don't know what nanofabrication or microfabrication is, here's my cheat slide. If you want to make something, you start with a flat surface, you take some off, or you add bits on, and you do that in some sort of pattern. Ta-da! That is nanofabrication in a nutshell. With the way you add it on, and the way you take it off, and the way you pattern it, have multiple ways of doing that, and those instruments can vary from something that costs $10,000 that you can put into your lab, up to something that costs $2.5 million that you need an awful lot of labs and an awful lot of people to make sure it works right. We're based in a very distributed manner. I sit in head office, and until very recently I had 4 people in head office. I now have 12, and that has its own little headaches. But what we actually have is 21 distributed sites around the country, and they host a sum total of around about 140 paid people, and there's probably another 10 to 15 who are in-kind support into that network. So we've got a lot of engineers, a lot of scientists, a lot of technical people out there running all of that equipment, and it's about $500 million worth of investment in tooling at this moment in time. To give you some concept of the kind of geographical changes that are spread that ANFF has to deal with, I thought I'd give you some comparisons. So this is Australia. This is Australia if you put it over Europe. So we stretch from Ireland, my home country, all the way through to Ukraine, and from Portugal to halfway up to the north, halfway up Sweden. So you can see that we do cover an awful lot of ground. If you put us on the United States, you can see that, you know, similar sizing from east to west. However, if we put us on top of Africa, we pale into insignificance in the top corner of Africa. So while, you know, we have similar sizing to, let's say, Europe or North America, we barely scratch the surface when you're talking about something that's as big as Africa. So the National Collaborative Research Infrastructure Strategy is how we've managed to sustain this over the last 15 years. It's a bipartisan federal government program. We have 2 main government parties, but both are supportive of what we do on a daily basis. That's been built over the time frame of this strategy from its very first inception through the roadmaps that we've done to update that on a regular basis. The last roadmap was 2016. previous roadmap was 2016. We've just had one in 2021, and the investment program will then fall out of that roadmap that we're all waiting with bated breath to see what the federal government are going to ask us to describe how we're going to support the themes and the challenge framework that they've put into the roadmap. So we're currently in a 10-year investment cycle, which means 5 years ago they put a whole load of money away. They gave out 5 years of that funding 5 years ago, and we've got another 5 to go. Again, I am in the privileged position that if you can get your government on board to put a long-term strategy in place, you really can do an awful lot. Until 5 years ago, we were running on year-to-year contracts, which meant our staff were on 6-month rolling contracts because it took us that long to get our contracts out. So they were on 6-month rolling contracts. That caused problems, but it also, what it meant was we were always looking for funding. We were always looking for, making sure that we were talking to the right people, that we were making sure that our impact was noticed. And what that did mean is that we could not stand back and look at strategy. We couldn't actually sit there and actually think, well, how can we grow? What's the next thing? Where are the gaps that we can fill? Because we were too busy just focusing on keeping the salaries for the people that we have. The last 5 years has changed all of that. Getting 5 years funding plus a capital injection 5 years ago has meant that, as I've just said, ANFF was able to grow from a headquarters of 3.5 staff. We've now got 12, and we've got many more projects working on the national scale rather than on the local scale, which was just keep the instruments up and running with experts beside them so that everyone gets what they need. So we're now being able to do a lot more because we've had that time to breathe and that time to actually decide on what is important and what is not important for our network. So the governments of Australia, I thought this might be useful because it's probably an analogy to the European, African and South American context. We have a federal government, that's where the majority of our funding comes from. But then I send it out to universities who are based in a state, they go talking to their state governments and they leverage that federal funding. And then we also have our institutions who also then chip in. Our local councils don't give us any money, but that's okay. They take the bins away, so we'll leave them at doing that. So we have 2 different levels of government who can provide significant funding. So again, privileged position, we can get more funding from one place, we can leverage it with another large funding source, and then we can get user fees on top of that. This is just to give you an idea of the breadth of things that with all that funding that we are actually covering. It's a very busy slide and I'm not expecting anyone to read it unless they've got really good eyesight and a microscope in their pocket. But it does mean that we have to have an awful lot of experts. But it also, if you can see that we also have areas where we have numbers of instruments. None of these instruments are in the same lab. They're all distributed across. So how do we make sure that our overarching experience, no matter where your user's coming in, is getting the same experience and the same level of training, the same level of data at the other end? So that's one of the things that we were able to focus on in the last 5 years. Quick stats, because everybody needs a stats slide. This is just our yearly stats. We say around about 3,000, give or take. COVID has knocked our numbers down a little bit in the last couple of years. But you'll also see that we also make and deliver items, and we also do an awful lot of training. So that 2,500 instances of training is every person who's done a training that's been signed off. So that's an awful lot of training when you're talking about 140 people to do that training. So how do we keep our network coherent, healthy, and actually believing that they are part of our network? All of the engineers and scientists are university employed. I gave money out to the universities employ the staff. So we have to make sure and spend an awful lot of effort making sure they understand that they are ANFF ANFF staffers. They may be a University of Queensland employee, but they belong to me. So this idea of culture, and I will not take any this was not my idea. I inherited this culture, so I'm very glad about that. But one of the key things that we did very early on in this organization was we developed the shirt. And this is the shirt. It has had many, many variations over the time. Sometimes it has white piping, sometimes it has, red stripes on it, but it is always a black polo shirt with our logo sitting on the breast. And we give these out on an annual basis. Every staff member has at least 2, and you get to wear them whenever you want to. Our engineers and scientists love wearing them because it's a uniform. They just throw it on in the morning, they walk to work, and they're all happy. We've also got nice business shirts, but the staff don't like wearing them. So these are what make everybody feel like they're part of that national network, because they go to a national meeting, such as this one over here, or they do some sort of media event like this one over here. Everybody's wearing the shirt, and we look like a really coherent and a cohesive family, and that tribe mentality really does make a difference for our organization. So other things that we do to try and keep our network healthy and try and coordinate across that huge distance. The Brisbane to Perth flight is I believe one of the longest internal flights in the world, where you don't need a passport, and it's 6 hours one way, 4.5 the other. Don't ask me. So this paper we published, I think it was last year, yes, 2021, was built off the back of, well, what kind of initiatives do we have that actually provide some sort of coherence and some sort of national strategy or national identity across that organization. And I'll talk about the 2 things that we highlighted in that paper shortly. But other things that we do, so our national staff retreat is something that we've put in place for the last few years. Obviously, COVID has prevented us doing it since 2019. I'm going to get off a plane on Sunday night, and I'm going to get on a plane on Tuesday morning to go into our staff retreat for this year, and I'm very, very excited. Usually we have about 80 or 90 people to go to it because everybody wants to keep their facilities open. This year I've got 140, so I don't think there's an ANFF facility open in the country for next week, so don't ask. We also have our learning management system, which I'll talk about momentarily, and the expert working groups. But we also do professional development awards. And this year we're really delighted. One of the the awardees of our professional development is actually one of our admin staff. So many times we get lots and lots of applications from our engineering and our scientific staff, but we rarely get them from the admin people, the people who do all that work that makes your lives so much easier. And this year we got one, and it was like an absolute no-brainer what you wanted to do. So I think that's a really good thing, that we're inclusive of all of the members of staff, not just when you're talking about professional development. We're not just talking about people going on training courses to do the next generation microscopy skills. And we also do travel awards. These allow us to get people from Perth to Brisbane and to spend time at those other nodes to talk to each other and to make sure that they can actually develop skills and create more of a network for the expert working groups. So the expert working groups we set up, again, these are driven by the engineers, and again, you can build these communities of practice in a lot of different ways. And the way we decided to do it was via the actual tools and the techniques. So we've built these communities of practice. We've also made sure that they are led by the engineers. One of the engineers is the leader. It's not done by facilities managers, and it's not done by HQ. So it means that they're actually talking about things they want to talk about. They're actually communicating in the ways they want to communicate, and they're meeting at the regularity that they want to meet at. So it's not being dictated by us, it's actually dictated by what they need from that group, which is actually working really well, and they're actually creating a lot of useful interactions and content. And it was also very useful because we set this up just before COVID hit, and what it actually managed to do is when certain of our facilities were closed and work had to be sent to another facility, they knew who to call. They knew who to send it to, and they knew how to explain it to, because they had that personal and professional relationship with them. So that was really useful. And of course, the pandemic also meant that we were able to do that. All of the online meetings, it became part and parcel. So they didn't feel awkward anymore doing those, and it just became something that happened on a regular basis. So it was a really useful thing to have in place to keep everyone connected during COVID. AMF Enlightened is our online learning portal. Again, this was triggered during the pandemic, because we realized that when we didn't have face-to-face training, because nearly all of those 2,500 training instances were face-to-face training instances in the lab. And we realized that we could do an awful lot to help that and to shorten those training processes by providing online content. I'm sure you all have online content that you use. Unfortunately, we couldn't find ones that we liked or that was at the level we wanted to pitch, so therefore we went and decided to start developing our own content, which is what we've gone and done. And we now have it, it's up and running. We also made the decision that this is free access. So all you have to do is click the button, register, and you can have access to all of our content that's in there. And what we're trying to do is also build this to allow us to help with training of technicians in the greater scheme of what's needed for nanotechnology industry. Because we also know that it's not just PhDs that are going to create an industry. You need workers at all levels of the industry. So we're trying to see how we can work into that training system to ensure that they're getting the kind of training that they need to support those, that industry. Nearly there. So there are some of the ideas of how we do to try and keep our network healthy. And one of the things that, with our stable funding in that 5 years that we've been able to do, is we had a look at where ANFF sits in the TRL levels. And 1 to 5, 6 is kind of mainly where we've sat. But we were trying to figure out what can we do to help people move into slightly higher levels. And we're trying to figure out what kind of support. And one of those things is the out-of-lab support services. So we've come up, we've developed and we're funded to develop a new platform which we're calling AMPC, which it's not AMP commercial, it's AMPC, and I should have changed that slide, my apologies. And the idea about here is when you've got great ideas and they're this close to getting something, whether it be new VC, new grant, new whatever it might be, but they need a market analysis. No researcher has $12,000 in the back pocket to go to a consultant to get a market analysis. Come talk to us. If you're an AMP user, you've used our facilities, it's an AMP product, we will give you the $12,000, we will get rid of that barrier and you can move on into your commercialization process. It's a really small way to help. It doesn't need a lot of capital, but it will be a small way to help. And we've got 2 levels. We've got the small one, which is about $20,000, up to about $20,000, and then we've got a slightly larger fund, which is going to about $100,000. So these are non-diluting capital to get rid of a barrier that gets you further along the commercialization. And all we ask in return is that you give us a shout out when you get the press release. So we think we're being very generous. So hopefully this helps some of those projects move through and gets those translations happening at a much faster pace rather than somebody spending 6 months trying to find $12,000 to do a report. That's the process. You don't need to know about that. It's on the website if you ever need it. And that's me. So thank you very much for your attention.
So much, Jane. So yeah, we for the sake of time, we will need to move to the next. But again, we will have. Please stay to the last discussion, and there's going to be questions certainly for Jane as well. It's good to be seeing. She said Australia was a small country, but actually I think it isn't. So it was a nice way of looking at the geographic connections within a continent, right? So for the next speaker, I'm glad to welcome again remotely, and now we're moving back again to South America, Leonel Malacrida. He's the head, okay, here's Leonel. He's the head of the Advanced Bioimaging Unit at the, which is a joint unit between the Pasteur Institute in Montevideo and the local university, la Universidad de la República. Thank you, Leonel.
Thank you, Alejandro. Can you hear me? Yes. Okay, perfect. Okay, thank you very much, Alejandro. Thank you very much for the organizers of this great event. I am sorry I couldn't make it to be there, and I thank you very much for the possibility to be remotely. What I'm going to talk is about some ideas that we are elaborating of how networks and regional hubs may help in foster the synergetic research infrastructure ecosystem in the region and across the globe. So basically, when we discuss about what to do, we went through all these questions, and I hope these two points that I stressed at the beginning will be my answers to some of all these different points that we would like to discuss in this presentation. So, but first of all, I would like to put a little bit in context Latin America. Well, Latin America is a large area. It covers 13% of the Earth land, and is basically in the 2020 was estimated of the 10% of the world population. And unfortunately, 1/3 of this population is under poverty. And this means that more or less 200 million are under this situation. In terms of gross domestic product, Latin America is on the $5 trillion, and we spend more or less on the 0.7% of the GDP to research and technology, which is more or less 3 to 5 times less of the European Union and North America. So as we all know, there is a limitation, and budget for research and infrastructure is short in Latin America. But I don't want to basically go into cry about this situation. My point is, well, what we can do with this 0.7% is the point, and how we can manage to take better advantage of this budget is what I will aim to do in this presentation. So I think the answer is to go globally, and go globally means to me thinking together as a regional networks. And in particular, I want to stress about Latin American Bioimaging and Centro de Biología Estructural de Mercosur, CEBEM, which are two networks well connected with Eurobioimaging and Instruct. And also under the umbrella of Global Bioimaging and Research Infra Consortium, who are basically that organization that put together, ideas and working groups to elaborate and take it better advantage of our resources. And also, I would like to highlight the role of the national cooperation in change this perspective. So to tell more about this, I would like to stress a case which was a cooperation between the two agencies of international cooperation in the region, between Mexico and Uruguay. In 2018, we put together a grant, which was not a scientific grant, was a grant to develop community between Chris Gould, Andres Camay, and myself, and with a big hope in the aims that is set in the title. So we thought that we can use this opportunity to work in leverage the Latin America Bioimaging Network. And I want to stress that this was a very humbling project with a round of 100K. And with this, very humble project, again, we succeed to set up a regional network as Latin America. And a long story made short is that Latin America was funded in last September in 2020 here in Montevideo. We have the LABI kicking off meeting, and we see together the 7 partners in Latin America with more than 75 participants, 15 countries, and we take the opportunity to sign a memorandum of understanding between Latin America and Global Bioimaging, which bring to the Uruguay and to Latin America for the first time the exchange of experience annual meeting. And I think I want to use this example of how very simple, and very humbling project can make a big impact in the region and globally. But to also stress how important are, the setting up of network, I want to first of all tell what is LAVI and what is LAVI aim. So it aims to promote coordinated training and education, as well as to support bioimaging career and development. And this is crucial for a region like Latin America, but also around the world, but also to establish collaboration and interact with other regional international networks. And in particular, also to explain what is the role of bioimaging to basically policymakers and stakeholders. But the next step, the next point that I want to stress is how important the network is as a unified voice to speak with stakeholders, with policymakers, and philanthropy. And in particular, I want to stress the case of Chan-Zuckerberg Initiative. This is not a propaganda for Chan-Zuckerberg Initiative, but rather for LAVI. And I want to thank Vladimir Ugasan who shared this slide to show a point which LAVI has a very important, impactful in the program. Chan-Zuckerberg Initiative, for those of you who don't know, is a philanthropy agency who is funding imaging because they believe imaging is crucial to drive better research and cure and prevent disease. And in 2020, I am very proud of have the chance to join this initiative with another colleague from Mexico, Paul Hernandez, and we were the only two in Latin America. And we feel very, very proud the first day, but the next day we discovered that we were alone across this region. And this region have a lot of more, great scientists that can join this network. And it was through LAVI, and it was through all the connection that Chan-Zuckerberg had the chance to interview with many people and understand what were the needs. And the needs were different of the grant that we applied in 2020. And I am glad to tell that in 2021, we have 13 grantees on all over Latin America and more than 0.3 million of funding, including LAVI, Latin American Bioimaging, and Centro de Biología Estructural Mercosur, CEBEM. So I believe that this is true, the really role of network like Latin American Bioimaging really change the possibilities and the future as a unified voice. So as a conclusion of this first part, what I want to say is we don't have an economic zone in Latin America. We have particularly a segmented region of economic cooperation. I'm not going to the details, but we should never underestimate the value of bilateral cooperation, because for a little project like Urumex microscopia, we change, a paradigm. And I truly believe that if we work together, we can make many bilateral cooperation, because we don't have an Eurozone, we don't have a Latin American zone, that can attract bigger flights. So I convinced that the network like LAVI and CEBEM are the key interlocutor to grantees enhance of use of research infrastructure, but also to develop better and broader training, coordinated effort in synergetic, the tackle and understand and use of the existing funding, but also facilitate the stabilization of interaction between low, middle, and high-end centers. And I will go in details in the next part of the presentation, but also work in elaborate better funding, as well of coordination of future adoption of technology, avoiding unnecessary duplication, and also transforming in more synergetic the research infrastructure capabilities in the region. So the next part is about how important are the regional hubs. And to do so, I want to stress basically a statement that Leon Chu, the head of the Advanced Imaging Center in Shanilia, Howard Hughes Medical Institute in US, always tell, and is what he says, equitably access research infrastructure, it not means that it's equitable access. And I will explain this in terms of Shanilia. Shanilia is an high-end optical microscopy facility open for all over the world, but not for Shanilia. And they cover all the expenses to go and do experiment there. And Leon show always this slide where there are many applications, hundreds of applications over the world, most of them successful. But he always tells that this is a big fail of Shanilia, because there is only few from regions like Africa and Latin America. And what I believe, and we discussed with Leon this many times, what I believe that is need is that we need to put in between this high-end research infrastructure, entry and middle-level research infrastructure, to make the climb of this mountain a little bit more easy. So we are aiming for develop regional hub as a catalyst of ecosystem for global bioimaging initiative, and we believe that these regional hubs are conceived to interact between intermediate and high-end level installation in the region and over the broad, and basically act as accelerator in uptaking cutting-edge technology, make training, dissemination, and embrace better practices in terms of providing services, establishes more an interactive and more nutritive connection with local and international industries, and also to democratize the access of this technology. But this can be a long shot, and we can, be frustrated. But what I want to show here is that we already have in the region centers who are basically very well core facilities, established core facility with different perspective. And I want to set the case of our initiative, the Integrative Bioimaging Hub that will be set in the Institut Pasteur of Montevideo, who is part of the network of Institut Pasteur. And we believe the Institut Pasteur is the key place because under the same roof, we have several core facilities that will be strong synergetic with this biointegrative hub. And where we are aiming is to put together the structural biology and the classical optical microscopy to showing the different scale from items to animals and understand how we can help to access the largest initiative around the world. I am glad that the Institut Pasteur direction has guarantee the creation of this grant. And I want to mention that what we are aiming is to put together this new concept, sharing expertise, because we have very short, community in Uruguay and across the region. And we want to basically put together new equipment in terms of structural biology and optical microscopy to join these two units. To the sake of time, I will say that this will be just a pilot program. We are committed to expand this program to other places, and we conceive this in cooperation with basically the two regional initiatives and the two international cooperation with Instruct-ERIC bioimaging. And we have, some grants already assigned and some grants are still waiting. And I think one of the big challenge is the funding for the technology. And this is something that it will be interesting to discuss later on. To finalize, I want to say that the idea of this is to basically put together all this cooperation, and this again can be a long shot, but we can start putting together little things, and we just sign an alignment between the three center, Advanced Imaging Center in Chanilia, the African Microscope Initiative that is funded yesterday, and us in Montevideo as a first step in connected entry-level and high-end level in terms of optical microscopy. And this was just a shake of hands between Karen Jacob, Leon Cho, and myself. And I think this is the way to go. We need to start walking and make the ball roll. To close my presentation, what I want to say is, well, we have events like this one and many others in where we sit together the different players, the different actors, like industry, academy, policymaker, philanthropists, etc. And so far, I think most of the time we are in this schema where we work as a multidisciplinary approach. And when we sit together in a meeting, we work as an interdisciplinary, but the need is that we need to go transdisciplinary. We really need to establish working groups that can elaborate better program for the future. And I believe that examples like ResInfra and ResVis as great examples of that, because we can establish regional international working group, very heterogeneous in the conformation, in order to understand the needs, elaborate plans, and propose programs to tackle the research infrastructure in a global scale. And to close my presentation, I want to say that I am convinced that for a region like Latin America, the regional hub and the regional hub well connected with the networks are the key to develop better opportunities with the budget that we have. Meanwhile, we will be working to expand the funding that are assigned in the region, and in order to broaden, the cooperation in terms of the region and globally. So thank you very much.
Thank you very much, Lionel. And we have time for one quick question, if there is any, for Lionel. Oh, we lost Lionel.
I am here.
Okay. Somewhere. Yeah, so Claudia. Yeah.
I'm going to apologize for the selfish of my question, but it's absolutely clear to me the advantages of those regional centers from the Latin America point of view. When we were discussing the collaboration with Europe and with our infrastructures, I wonder if you could envisage what are the advantages to increase that collaboration? What the regional hubs you think will do towards the collaboration between Europe and Latin America?
Well, your question is very, very interesting, Claudia, and we have the chance to discuss many times about this. Well, to be honest, I think the stabilization of regional hubs should be, in terms of, in particular in Latin America, a big change in the paradigm, that we will concentrate our effort in those places that they already exist. I want to, during the presentation, I was thinking how to stress the point that, of course, we can create new places, but we already have in the region, prevalently spread around, a lot of capabilities. First of all, in terms of human capabilities, and also in terms of research infrastructure. So if we can, elaborate on these places, make at the beginning stronger what they already are good, then we will go to the next step, which is to connect and to share, the disciplines that every of the different regional hubs are expert, right? So we can extrapolate from one place to another. And I think the most important point in cooperation between, Latin America and other continents is, well, there are a lot of opportunities. And the example of Shanivia is one of the best examples of how, claim for an open access core facility, for an open access research infrastructure center is indeed, at the end, a little bit of we are lying ourselves, because there are barriers that cannot be, just tackled by open the door of a center. You need to go to the place and you need to speak with the people. You need to understand what are the questions. You need to understand what are the needs, and you need to help them to maturate in order to take advantage of the open access core facilities and centers across the globe. And I hope, this little step, like, these sister core facilities, or, the interaction between Latin America and Europe, like we are working together with Instruct, with SEVEM, with Eurobioimaging, with Latin American Bioimaging, will set examples of success of how this can change the future.
Thank you. Okay, so I think it's been really nice to see the different ways that each region has been developing to make interactions between sites. So this dispersion and the richness of having different research infrastructure and using them better, since they're so difficult to install and maintain and so on. So before going to the discussion with all the panelists, we do have a video, a short video, that has been prepared by Global Bioimaging. It's been referenced already. I think it makes sense in the sense that this is a global vision, right? So let's maybe just see it. It's a couple of minutes, and then I invite you to the final discussion.
Understanding life, imaging. From a single cell to complex ecosystems, imaging technologies are crucial. In Brazil, scientists use microscopes to study tropical diseases and evaluate the influence of climate change. Researchers in Israel employ underwater microscopes to observe life beneath the sea. Imaging technologies also help us understand the human body and improve diagnosis and treatment. To solve humanity's greatest challenges, imaging scientists and infrastructures must be connected.
Global bioimaging is bringing together people, the communities in imaging. The inspirational stories of where people come from, and that there's so much more than just a day-to-day life in a microscopic lab. There's a world out there that we are making an impact in, and we should see that bigger picture.
So we're building the Latin America Bioimaging Network, and global bioimaging has allowed us to have a stage to connect with the rest of the world.
The impact is immense, I would say, because it was through the global bioimaging that I come into contact with a lot of absolutely fantastic and vibrant imaging communities.
Our mission is to promote and connect imaging scientists and imaging research infrastructures from around the globe. One way to be part of it is to join our working groups. So there are several with different topics, and anyone can join.
It's togetherness.
Exchange.
Cooperation.
Connection.
Community.
Inspiring.
So thank you, Auntie, in the name of Global Bioimaging. She's right there, so she was talking to us from the video. So I would invite Silke and Jane up front, and we do have online Udunna and Lionel. And go ahead. Right here. Here's the microphone. And maybe so I think we have seen all these different examples. Oh yeah, thank you. Is this working? Yeah. So we've seen these different examples, and also the sort of the perspective that each region, different organizations in each region have developed to link different geographic sites, right? Within Australia, within Europe, within Latin America, and also transcontinentally, North America, and so on. So maybe, apart from some other questions from the audience, I will launch a first thing. Instead of focusing on difficulties or challenges, we have so many that maybe focusing on some, positive things about being able to link different geographic sites. And that would be, what are your ideas about specificities of each region, right? So from my point of view, which I come from life sciences, so from health, I could just throw some ideas, like the fact of having many different, that biodiversity is really site-specific in many ways. So if you study microbiota, it's not the same thing to study it in Europe or in the United States or in Latin America and so on. So diseases, there are diseases that are epidemiology is not the same in every region. And so that gives us opportunities. So taking advantage of the different disciplines here. So maybe starting with Jane, what do you see as interesting from your point of view in Australia? And maybe what could be a way of thinking in other sites beyond that would make sense to link?
So working from the point of view, we make things in all of our sites, regardless. But what we do is we've very consciously made sure that they are embedded in a particular research ecosystem. So for example, I have an OptoFab node. They make a lot of optical fibers. They do a lot of photonics. But I also have state-based nodes which work on a lot of quantum technologies and so on and so forth. And being able to segregate them into those kind of research specifics allows us to actually leverage into state-based priorities. So each state has different science priorities and industry priorities. So New South Wales is coming on board with the fact that they want to be the quantum state in Australia, which is fabulous because we've been supporting quantum in New South Wales for 8 to 10 years. So we've got it all sorted, and they can then now come on and support the industries that we've been seeding. So I think there's a lot to be said for being able to have specific facilities that are doing specific things in different areas. And because we've got so much space, that makes it really easy. Another example of that is that we have over in Perth, right on the far side of the country, they do a lot of defense-based things because it's really hard to get there. And so people, it takes time and effort, but it also means that they have to be very self-contained. So they have to have most of their process trains from start to finish in the one place. But they're all specific for MEMS technologies. So again, we're taking advantage of what they're doing on the ground. We're taking advantage of where they are and what their particular state governments are actually interested in funding. Because as we all know, if you've got the government interested in funding it, it's a lot easier to actually get the funding.
Yeah, please.
Yeah. Okay, so from the European perspective, there are big differences from country to country in terms of size of the economies, possibilities that they have to set up research infrastructures and facilities. And in an organization like Instruct that is distributed across a range of countries at various levels, it is very important to find ways to bridge these gaps in the best possible way. And this is through linking less developed countries to more developed countries to provide access to facilities that they will never be able to afford in their own countries, but they have scientific communities that would make very good use of these facilities. And this is complemented by training programs that helps to improve the usage of these facilities.
So I see them better there. So Udunna, what's your take? Maybe just in parentheses here. So Jane and Silke have mentioned mostly, which is very good, how to interlink different sites within their continents. And that's for sure one of the important things to think about. Also, what's the point of cooperating internationally? So, Udunna?
What's the point of cooperating internationally? Okay, so I'm going to answer this from the African perspective, because from the Canadian perspective, it's kind of straightforward. From the African perspective, the point of cooperating internationally is also you can draw in people to help build a collaborative network to sustain and support the infrastructures that's in place. I think Lionel answered this in his last question about not building something new, but using the infrastructures that are there. I gave 2 examples of infrastructures that are in Africa, and there's a few more. There's BioRTC, so the Biomedical Research Training Center in Yobe, Nigeria, and there's also the Centron facility somewhere in Senegal. I don't remember where it is, but there are existing infrastructure, and the global community can come in by either supporting, sending the students to train there, supporting early career researchers that are based there that don't have access to grants. Example is what Esther did with the Cubic. Most of the Cubic grants, she's on them, but she's not typically the PI. So she's a co-PI on international grants. She has NIH grants, but she's never held an NIH grant as a PI. And that's because she had collaborative networks with people from outside where the grants are, which is what we're trying to do with my lab, is trying to tap into Canadian grants, but support the local researchers that are there to use those infrastructures. So that's one way of doing that.
Right, thank you. Lionel?
Yes, thank. I think, I was, during the presentation of the other panelists, I was thinking about how important was for us, to interact through, Latin America and then through global bioimaging. And I'm very happy that we have this video that was recorded in part here in Montevideo during the last event. Angie and Yara were behind of all this recording here. And I want to stress, being part of global bioimaging for us was huge in impact. And the reason for why is because we understand from the difference of the different partners of global bioimaging how we can elaborate on better, perspective, but with the already experience from others, right? And this is fundamental for a region like Latin America, and I would like to say also for like Africa, because every chance that you have to risk is a big pay. There is a big payroll to pay if you fail, right? If you do wrong, if you go bad, because your funding is always short. If you do things that reinvent the wheel that eventually fail, the cost will be very, very high. So I believe that the cooperation in terms of networks between, intra, like Latin American Bioimaging or SEBEM, is key. Is key to cooperate much better international.
Right.
And I also want to stress something that Shane mentioned, which is the identity. I think we need to make way more T-shirts and mugs over the Latin America and over the world to really, engage with people and having them as be part of something, be really, not just say, I am happy with this is happening. I am very happy that this is happening. I want to be in this group, I want to get into this boat and navigate, right? So I think this is really important. Networks make this sense for community development, right?
Great. So any further question from the audience to the speakers? Yeah.
I have interest in knowing the details about this funding scheme for companies in Australia. I think it was in the fabrication lab, if I remember well. You pay a sum of money to companies for them to prepare the samples to be measured at the lab. And the question will be whether is that a lump sum or are you asking there for receipts at the end to grant that money?
We don't give money to do any research at all, in any way, shape or form, to companies. I may have misrepresented. So the AMPC funding that I'm talking about is out of lab support. It is not for any kind of research. One of the central tenets of the NCRIS funding is that we cannot use it to do research. Our funding cannot be used to support actual research. It can only be funded, it can only be used for research infrastructure. What we provide to those companies, or it doesn't have to be a company, it can be an early stage entity, which we describe as anything that is now a thing that you think at some stage you will be able to sell. So it's a late stage project that's got proof of concept done, that we will help you get that to the next stage. And it might be that you need to make 2 of them and show them to a VC, but we won't support you to use our facilities, but we'll support you to get a professional business case written. So it's always out of lab support for AMPC. And no, we don't care. We get the invoices directly to us and we pay the invoices directly so they don't go through the company or early stage entity.
Thank you. Okay, I think we are done. And I want to thank again very much the 4 of the speakers we've had in this session. I think they were amazing. So, and thank you for your attention, participation. See you later.